Hello, I'm Mike Wilson, Product Manager of Display Measurement Solutions for Westar Display Technologies. Here today we're going to talk about our Gray Level Response Time Measurement System, or GLRT. The GLRT system consists of several components that we manufacture: our TRD 200 or Temporal Response Detector, our T-Drive Video Test Pattern Generator, our software, the GLRT software that's running on a laptop today, and then the display that you're testing, the display under test. Now, I'll go into these in a little bit more detail. The TRD 200 is connected to the PC via USB. The TRD 200 has internal data acquisition, so it's measuring at up to 500 kilohertz the luminance output of the display under test. It's sampling that, storing that, and sending the data to the software for analysis. The TRD 200 is also connected via coax cable to the T-Drive for trigger, so that we can synchronize the test pattern with the measurement. The T-Drive is our video test pattern generator box. It's capable of driving both monitors and TVs. It can also drive bare panels. For example, it can drive panels via LVDS or embedded DisplayPort, and then it can drive TVs via HDMI or DisplayPort also. Now I'm going to start the GLRT software, the Gray Level Response Time software. And we'll do a series of measurements. So what's happening here is the software is commanding the T-Drive to put up blink patterns on the display under test. The TRD is measuring the rise time, the luminance rise and fall time of these blinking patterns. And these are not just black and white, but also gray to gray that we're measuring. Each of these is being recorded, and then the data is being logged in graphical and tabular form in the GLRT software, which we'll go into more detail in a second. This is our GLRT software user interface. So what we have here is up on the left side is T-Drive control. So this is where we can manually control the T-Drive to put up test patterns on the display under test. The window next to that, the GLRT 200 window, is where we control the actual Gray Level Response Time software. And this is where I'm going to spend the majority of my time discussing. And then we see the results here over on the right. So in the GLRT window, this will automatically control both the TRD and the T-Drive, both the driving the display and the acquisition. So if we look at the list of settings here, I'll go over them in order. We have sweep color, so you can make that white, red, green, or blue. It's a drop-down window. Normally we do white, and that will just do gray to gray response time. If you wanted to do gray to gray of a specific color, you could do that. The auto adjust target for the TRD, this sets the gain control, and it's set in voltage from 0 to 5 volts. We would typically set it around 3 volts. We've dropped it down to 1.5 volts for displays that have a lot of overshoot to prevent saturation of the TRD, Temporal Response Detector. The gray level mode, this allows you to specify, right now it's based on spacing. So what that means is, looking at the next lines down, we're starting at black, gray level 0, going to gray level 255, which is complete white for this panel. And we're doing it in 7 steps. So what we have over here, you can see on the right, is a 7x7 grid of gray levels that we're going to be testing over. You can also make this user-defined, where you can specify a collection, a list of gray levels that you specifically want to test over. You would do that if you wanted the gray level spacing to be non-uniform. Next, we have the sample rate. The maximum sample rate for the TRD 200 is 500 kilohertz. You can make that lower if you want. All it does is it saves memory if you make the sample rate less than 500. If you're dealing with a really fast display, keep the sample rate high. The blink period, this is how fast we're commanding the display to blink. If your display is slow, you might need to stretch this out. Most displays you can get by with a half-second blink period, 500 milliseconds. If you see that your display, the response time is long and not settling out within a half a second, you can make that longer. Next is level high and level low. What these are is where we're measuring response time from. The standard is normally on rise time and fall time, you're measuring from 10 to 90% of the signal level. And so that's what this represents. You could change that to make it 80 to 20 if you wanted. Next is average list. This gets a little complicated, but basically it allows you to specify how many measurements or waveforms you're going to average together for a particular set of gray levels. And then finally, the blink mode is how we want to blink the display, whether we're going to blink full screen, or we can blink a rectangular window, or we can just blink a line, and you can specify the line height. So this is all sets up our acquisition. Next is the filtering section. So when you're making these high-speed measurements, there tends to be a lot of noise that needs to be filtered out. And here we have a range of filters that you can apply to the waveform. Low-pass Butterworth is a standard low-pass filter, and that's one we use a lot. The next most useful one is a moving window average, and this is helpful when you want to remove ripple from a particular waveform. It's also helpful if you want to measure motion picture response time, or MPRT. You can do that measurement directly by setting the filter window width to the display frame rate and then turning correction off to no. That will give you motion picture response time measurement. All right. Now to actually run this measurement, all you have to do is click Start. So we click Start, the display starts blinking, and we start making acquisitions. And here in the window down at the bottom, you can see the actual waveforms, the rise time and fall time. We're recording, it's displayed on the graph here, the rise time, the fall time, and it's also being displayed in a table. So as you see, we're catching both rise and fall simultaneously, so both edges of the pulse. That's why these two blue boxes are here, highlighting what the most recent measurement. So as you can see, it's going to make 42 measurements of gray to gray response time, and it's only going to take us a minute or two to do that. So as it's filling this table out, it's changing the blink level. Right now it's going from 212 to 128. Now it's going from 212 to 85, gray level 212 to gray level 85, and it keeps progressing until you get down to the lowest gray levels. As you see over here in the waveform window, we've got this display at some gray levels has a tendency to overshoot, and we're capturing that overshoot as well. And that's being displayed and recorded in some windows over here. As this is running, I'll show you, we've got this tabular view, but we also have a 3D plot of the response time. So here we see the same data, only displayed in 3D form, so you can see the response time. And then we can also look at the overshoot and undershoot, and look at that as in plotted form as well. This data can be exported. So each of these graphs can be saved as a PNG or JPEG file, and the data tables can be saved as comma delimited text files that can be imported to Excel. But in addition to that, we have the ability to record a sweep data file, and that records all the information, including all the samples of the waveforms. And you can open that up in the GLRT software again to look at your measurement, your previous measurements. You can refilter them, you can change filter settings, you can do everything except make a new acquisition, because you can basically do this offline. So we've got one more measurement to make here. Okay, so that was the last. We've done a 7x7 grid of grade levels. This is what the plot of the data looks like. For this display, actually the response times are all fairly uniform. And then the overshoot, undershoot, we had a little bit of overshoot here at grade level 85. So we can see the overshoot here. And a neat thing to look at is on this response time data, you can click on any one of these numbers and it'll pull up the waveform down here in the waveform view. So you can see the unfiltered and the filtered data. You can see the rise time and fall time. And as you click on different areas in the data table, different waveforms come up. So this is the 0 to 42 gray level. You can see it's very dim. And this is white and black. And then, as I mentioned, you can change filter settings after the fact. So this had the moving window average turned on. I can change this to a Butterworth filter. And this applies less filtering, so you actually get a better response time measurement. And we can look at our response time plot here again. And you can see that the data in the table updated based on your filter settings. The next thing that I'll mention is that we also have here signal analyzer for the TRD200. This allows us to make manual measurements of the display. So I can manually go over to the T drive and display white on the display. I can adjust my TRD for that white setting, and I can start an acquisition. And this would be useful for doing flicker measurements. In this case, this display doesn't have very much flicker. All you see is just low-level noise here. If the display had flicker, you'd see a peak somewhere along here. So here you're making individual measurements. You can also make continuous measurements. This works just like an oscilloscope or a signal analyzer. So this upper area is time domain response. So this is like an oscilloscope. And the lower area is frequency domain, or the FFT, Fourier transform of the time domain signal. So you can see things in frequency domain. So this is useful for flicker, and this is useful for a detailed look at response time. So for example, if I put up a blinking pattern and I'm going to trigger on that, so I'm going to use my external trigger from the T drive, and I'm going to click start. Just a second. I was set for white and black. Apply. Click start. And then here you see the rise time and the fall time and the acquisition for a single measurement. So this is looking at just, we can enable rise time and fall time. So here we see a 5 millisecond rise time and almost a 5 millisecond fall time with no filtering applied. And again, you can apply filters to this. So low pass Butterworth smooths things out a little bit, gives you a little bit more accurate result. If you're measuring flicker, you would have no filter applied, so none. And you would be looking at a steady state display, so you would not be blinking it. I'm going to look at a mid-gray. So I've driven the display to 128. Make an acquisition. And let me zoom in down here. There's a little bit of flicker, it looks like. right here, we can drag these cursors around too. So right here at 60 Hertz. So that's pretty typical. So this would be a little bit of flicker that we see at 60 Hertz. And you can read the flicker level down here. It's minus 41 dB, so it's not really observable. And that's it for our gray level response time measurement system. Thank you for watching. If you have any questions, you can contact us. You can contact me directly, wilson@westar.com, or also look us up online, www.westardisplaytechnologies.com. Thank you.